Hello and welcome to this episode of T-Tech. Today we're going to discuss how to avoid getting your pfSense compromised. So, how to better secure pfSense. Now, what we're talking about here, I want to say right off the bat, pfSense is secure. This isn't a vulnerability that would normally get a CVE. This isn't a buffer overflow or anything like that. So it is secure. I just want to present that under certain circumstances, this can be a viable attack and hard to detect. So what we're talking about here is normally we're gonna first discuss the Web Configurator versus the Unix Shell. Now, normally on your pfSense, you're the administrator here. You have your web browser open, and you're using HTTPS to talk to the web interface of pfSense. And that consists of PHP code and some HTML elements, among other things. And the HTML elements give you things like input boxes and places to put information, like IP addresses, port numbers, etc. And what the PHP does is it processes those. So when I tell it, certain IP address and then hit save, that sends a post request to the interface and it sends that information. And after it sends the information from your browser to here, the PHP then does its processing further down in the system. And what it ends up doing is writing, like it abstracts what those boxes mean, for instance. So like a LAN IP address, it takes that IP and puts it as a configuration value. And where it stores that is in config.xml. And this is where any changes you make on the web interface are stored. Okay? And the thing is, the config.xml contents aren't the raw commands that the system actually runs. What has to happen is those elements in this config.xml file, like for instance a firewall rule, they have to get passed through parsing programs. So these are a mixture of PHP and Shell on pfSense, and there is a lot of them though. And what they do is they abstract things like that LAN IP address or that firewall rule or the username, and they turn it into commands, and they pass pieces like the LAN address into, for instance, the ifconfig command to put that IP on the interface. And the full command, once it gets assembled, then goes to the operating system, which is FreeBSD. So in that way, the only way you can get commands to execute on the operating system is through the web interface. So only what the web interface can do is shown to you. So in contrast to that is the Unix Shell. So here, instead of using a web interface, what we have is the administrator. He is typing the commands he wants to run directly into a shell, such as this command, pfctl-si, which just shows you information about pf. And then when we hit enter on that command, exactly as we typed it, right or wrong, goes into the operating system, and then it executes. And then when it's done, it returns. There is no abstraction in this case. It just runs directly on the system. Now, what we end up doing is we combine both of these concepts here to create an attack. So what we're doing here is bypassing the web configurator. So we still have the web configurator and we can still put commands in there and everything. But the difference is we have another way to put commands in. We have our shell and we do exactly what we just discussed. The difference is the commands that get executed here and passed to the operating system never hit config.xml. So, there's two bad things about that. The most obvious one is if it's not in the config.xml, the web interface, it is not configured. For instance, it doesn't exist. So the web interface won't be able to show you like a port forward for, a certain, like port 80 that you didn't know you had because we executed that command directly rather than typing the port forward in the web interface. So we're going to show on a demo next some of the things that can happen, but it'll make more sense once we go to the demo. But the main thing is, if we bypass that and put the commands directly in there, we're blind, basically. Now, how can this happen? Well, obviously physical access, because you can go to the shell, you can get root immediately, and that's how we start the attack. But there's another way. If you enable SSH, and you just enable that there, and you have a weak password, or you're not using key-based authentication, what happens is they can get into the system there and do the same type of attack. Anytime we're exposing the shell, either with physical access or secure shell, all bets are off because this attack can take place. So we're going to explore that and do a demo of it in the next section. So I hope you enjoy that, and I will see you in a second. Alright, so now in this part, we're on the pfSense. I've logged into the web interface at 192.168.10.1, and you see here it's LAN side. And then we have one WAN. The interface configuration doesn't matter, as we'll see in a second. All I've done is put the services widget out there, and then I have the default dashboard and interfaces tile, and that's all I have. So what we're going to do is pretend, basically, we went in here to the network closet, to, the desk, whatever it's on, even the cloud provider, if that administrator got a successful phishing attack. If we get into Azure or AWS in the dashboard, we have access to this. So that's something to think about as well. But anyway, we have access. That's the point. And if I hit option 8, I have a shell. If I say who am I, and I'm root. Well, guess what I'm going to do? I'm going to go ahead first, and I'm going to disable Syslog D. Okay. Now, I'm going to take you step by step. This is provided you're logged in to the interface while this is taking place. Just 1 second, it's virtualized, so it might be a little slow. So if you're logged in, you'll see that Syslog D stopped. But that's only if you're logged in. So from here, we're going to go ahead and add a user. We're not going to create a home directory. Okay. Oops, I apologize. There we go. 4Ws is the username. We're going to put him in the wheel group and leave all the other defaults. Okay, doesn't matter. It's a system user. It doesn't change this attack. So after that, we're going to do package install sudo. And install that. Now we're going to go into user local /c sudoers. And this is the file that controls the permissions. And under here, we're going to type that username we created, and we're going to make it so the user can do everything. And we're going to save that file. And now we want to make a file etc rc.local, and this is executed on boot. And we're just going to run sshd, like so. And then finally, before we restart the system logging daemon, we're going to go ahead and go into var log, and we're going to do change flags schg system log. And now we're going to simply start back up the system log daemon. Okay, and you will notice that error. That's because we've made it so not even root can access that log file. And the reason is because that's where the sudo commands and us starting up the daemon and everything will be, so that helps hide the attack. So then if we exit out of there, okay, and I'm going to go ahead and refresh the page again. Okay, as we can see, if we were around, Syslog D is now running again, so it just seems like a little hiccup. And if we go to status, system logs, and we have our logs here. I'm going down here. Well, nothing that strange that I see. I mean, do you see anything weird? I don't. See, login, that just looks normal, like physical access. Syslog D exited on signal 11. We had a little bug. But other than that, it looks like everything is okay. And I'm not seeing anything strange. Okay, well, here's the thing. If we do try to detect the attack, how I said about bypassing that config.xml, that's already done. So we've already made a user, we've already started SSH, and it's persistent. So if we go to advanced to check if SSH is running, and if we scroll down here, it's not checked. And the reason it's not checked is because we didn't start it, we didn't configure it through the web interface. And let's go to system as well, user manager, because I know you're probably thinking, well, the user will be there, the user's not. And if we go to system package manager, our sudo package isn't installed either. It's still available and everything, but when you install a package, that gets logged in the XML, and that's how this knows to show you that it's installed. So the other interesting thing is we can log in again. So if we open up, okay, we have putty here, and all we're going to do is type www at 192.168 10.1, the LAN side of this here. Oops, I apologize. I actually forgot to fully start it. So, I mean, obviously, because of a reboot happening, that would have worked anyway. So yes, other than doing service SSHD one start first, it has to generate the keys. But that doesn't take away from the effect of this. So if we do netstat.an, well, let's log out of here now. We'll open that back up. And now we'll log in how we had said. And we'll just say yes. And now we're logged right in. And we can run, for instance, showing the rules. And then if we go to status, system logs, okay, as you can see, our sudo command is not there. And that's because it can't write to the log file. So if we try to go back here and check again, it's not there. So as far as we're concerned, the system is fine if we just depend on the web interface. Now, I'm not going to leave you just like that, showing you how to attack this. The other thing as well, while we're in here, while we're in the shell, I want you to see as well, we can go right into that CF file. We can export the file. We could grep out the password. And then I could pass that through hashcat or whatever I want to try to brute force it. If I wanted to as well, you could go to where was it here? And go to conf.default. And you can change the default settings when you reset the system. Now, I'm not showing you this to scare you. I'm not showing you this to say pfSense is insecure. It isn't insecure. It's just certain settings that allow this to happen. So in the next part, we're going to talk about ways you can protect yourself from this and prevent it from happening in the first place. Because if you go through the web interface, this attack is almost impossible to detect. Almost. Everything has a way, but that's what we're talking about here. That's the attack. There's many more things we could do. I'm not showing those because this is enough. If you want to try it yourself, I'm sure you can, figure out the parts I'm leaving out that you can try yourself. But anyway, we're going to stop there with this section. I'll see you in the next one, where we're going to talk about how to protect yourself from this attack. So what we're going to do to help prevent this is under the System Advanced tab. First thing we want to do is, if we can help it, avoid enabling SSH. In something like pfSense, there's very little reason, other than if you know about the shell and the OS underneath, to enable SSH. As we've seen, it actually takes away from the security potentially. And the other thing that could avoid all this happening in the first place is check password protect the console menu right here, and then hit save. And if we do that, and we pull back up this here, you see, now I have to log in. So if I didn't know the admin password, I would have no way of logging in to do this attack. Alright? So that is the advantage there. I do want you to realize, though, it does depend if it was done already or not. Because this is a normal Getty process where I can log in and I still have that the access. Okay? But anyway, the last thing I want to show you is the fact that we can detect SSH. So because it's running if I go to diagnostics, even after compromise, and I go down to test port, if we type our IP address, 10.1, and we try to test the port, and we show remote text, which is just the banner that comes up, and we test that, it tells us here that it was successful, and it shows us any text in the form. We can see OpenSSH is running. And I mean, that's obviously something that is very perplexing to us as the administrator because, well, it's not enabled. So that's the interesting thing. So the last thing we're going to do is reset the system, and I want you to see how this actually has persistence. Alright, so it doesn't matter if we do this from the shell, or, over SSH or physical access or anything. If we go to diagnostics, factory defaults, we're going to factory reset, and we're going to say OK. As you can see, it moves to all user configuration, and then it will give us these settings back. We're going to go ahead here. Alright, it's now rebooting, and I'll be back in a second. Alright, we're back on our default pfSense. We're going to log in here with the defaults, admin and pfSense. As you can see, we're on the default screen, and we're in the first part of the wizard. But what I want to show you, we can log right in to the machine. Right here. And we still have that user, and that user still has all the root privileges and everything that we had before. If I go into conf, I see there is a config.xml. But, it's just the default one. So that is that is this video. So remember, enable the password protection on the console, and don't enable SSH if you don't have to. Number 3, don't allow untrusted personnel to access your pfSense, whether it's in the cloud or whether it's on premise. I do understand why they have the setting as that default, because if you have physical access, you're assumed to be a trusted administrator of the system. But that's not always the case, and this can still happen. I just want the users of pfSense to be as safe as possible. I think it's a great piece of software. I really do. So, lastly, this attack, it's not just pfSense. It can apply to IPFire, a smooth wall, an untangle, pretty much any system that abstracts it with a web interface. But to be honest, the convenience and everything they've done to make it easy and quick to use outweighs this small risk. Once you get physical access anyway, you could reinstall the operating system if you really wanted to. So I hope you enjoyed it, and as always, it's Tyler with T-Tech. Thank you very much for watching, and have a very nice day.